Assalamualaikum. We are from Group 5. We will be presented about satellite communication. So firstly, I would like to introduce myself. My name is Fatihah Binti Rosman Tarmizi, and the other members are Syazana, Hazirah Binti Azman, and Batrisyia Binti Zubir. So we will share with you a video of satellite communication, introduction to satellite communication system, types of satellite system link, and a block diagram of Earth station. So let's watch the video first.
Satellite communication. A satellite is an artificial body placed in an orbit around the Earth or another planet. The communication satellites relay around the world telephone and fax messages, television programs, radio signals, and so on. Principle of satellite communication. The process of communication begins at an Earth station. The Earth station is an installation designed to transmit and receive signals from a satellite in orbit around the Earth. Earth stations send information in the form of high-powered, high-frequency signals to satellites that receive and retransmit the signals back to Earth. These retransmitted signals are then received by other Earth stations in the coverage area of the satellite. The area which receives the signal from the satellite is known as the satellite's footprint. The transmission system from the Earth station to the satellite is called the uplink, and the transmission system from the satellite to the Earth station is called the downlink. Here you have the schematic representation of the principle of satellite communication. To avoid confusion, the uplink and downlink frequencies are kept different. Before designing a satellite communication system, we must choose the orbit in which the satellite is to be placed. Orbits are of three types, namely geostationary orbit or geosynchronous orbit, polar circular orbit, and inclined highly elliptical orbit. Geostationary or geosynchronous orbit. In this type of orbit, the satellite takes 24 hours to circle once around the Earth. Since the period of revolution of the satellite is equal to the period of rotation of the Earth, the satellite appears to be stationary in the sky. For this reason, this 35,900 kilometers high equatorial orbit is called a geostationary orbit. The geostationary orbit is also known as Clarke's orbit. This is in honor of Arthur C. Clarke, the man who first suggested in 1945 that satellites in geosynchronous orbits could be used for communication purposes. Entire Earth can be linked or covered by the communication network if three geostationary satellites are placed at the vertices of an equilateral triangle. Each of the satellites covers 1/3 of the globe. Polar circular orbit. This type of orbit is placed 1,000 kilometers above the Earth's surface. It passes over the poles. The angle of inclination of this orbit is 90 degrees. It scans the whole Earth in every 12 hours. Satellites used for weather monitoring are launched into a polar orbit. Inclined highly elliptical orbit. It is used for establishing communication with regions at high latitudes. The angle of inclination is equal to 63 degrees.
So what is satellite? Satellite is a self-contained communication system with the ability to receive signals from Earth and to retransmit those signals back. Satellite integrated receiver and transmitter of radio signals. Satellite has to confront the shock of being accelerated during launch up to the orbital velocity of 28,1100 km or equal to 17,500 miles an hour. Satellite has to operate with space environment where it can be at extreme temperatures, which is negative 150 degrees Celsius until 150 degrees Celsius. Satellite can last up to 20 years. The material that must be used to make a satellite must be lightweight, long-lasting materials, and must be small. Satellite consists of communication system, which is antennas and transponders, power system, and propulsion system. So sunlight is a main source of power, but when the sun is blocked by the earth, it will use the batteries. The batteries are recharged by the excess current generated by the solar panels when there is sunlight. So next, a satellite at an altitude of 35,786 kilometers or equal to 22,236 miles above Earth's surface will be moving at the same speed as Earth's rotations. Satellite can turn away from geostationary orbit every year from north to south or east to west because of the gravitational pull of the moon and sun. So what is geostationary orbit? I will explain it later at the next slide. So the tracking telemetry and control (TT&C) system of a satellite is a two-way communication link between the satellite and TT&C on the ground, allows a ground station to track a satellite's position and control the satellite's propulsion, thermal and other systems, and monitor the temperature, electrical voltages, and other important parameters of a satellite. So there is three different orbits that satellite operate, which is low Earth orbit (LEO), medium Earth orbit (MEO), and geostationary orbit (GEO). So LEO is positioned at an altitude between 160 km and 1,600 km or equal to 100 and 1,000 miles above Earth, while MEO is positioned at 10,000 to 2,000 km or equal to 6,300 to 12,500 miles from Earth. And the last one, GEO, is positioned at 35,786 km or equal to 22,236 miles above Earth. And satellite at GEO can complete one orbit in 24 hours and remain fixed over one spot. So usually, satellite will be used at GEO because a signal that is punched off takes approximately 0.22 seconds to travel at the speed of light from Earth to the satellite and back. While LEO and MEO is not operated because of the inhospitable environment for electronic components in the area, which is caused by the valent radiation belt. So LEO or MEO is mostly used for mobile and voice services because it is to avoid the signal delays, and GEO is used for broadcasting and data application. So lastly, there is a satellite application, which is there is three communication services, which is telecommunications, broadcasting, and data communications. So for telecommunication, it is telephone companies as well as wireless, mobile, and cellular network providers. For broadcasting, it is like radio and television, and it delivering programming to cell phones and other mobile devices. So for data communications, it transfer of data from one point to another. It is to facilitate the transfer of data through the use of very small aperture terminal VSAT network.
Bismillahirrahmanirrahim. Okay, next, I am Nur Syazana Hazirah Binti Azman. Okay, next, I will present type of link. Okay, there are two links in a satellite system, which is uplink and a downlink. Okay, uplink. Uplink is a link from a ground to the satellite, which is downlink is the link from the satellite to the second ground station. Okay, next. As we can see, uplink is from antenna to the satellite, and another is the from a satellite to the antenna. Okay, next. What are uplink and a downlink? Okay, in the communication, there are from a satellite to the ground is called downlink, and from ground to the satellite is called uplink. Okay, when uplink is being received by a spacecraft, at the same time, downlink is being received by Earth. So that is called a communication two-way. If the uplink happen, is only called upload. When the downlink only happen, is called one way. Okay, but mostly in the communication satellite system is called two-way. Okay, as I put, you can see for a user satellite system, station to the antenna, and from uplink to the satellite. Okay, from satellite to antenna is downlink. Okay, next. A typical satellite link involves the transmissions or uplinking a signal from Earth to the Earth station to the satellite. Okay, the satellite then receive. I repeat, the satellite then receive and amplify the signal and retransmit it back to the Earth. Okay, where is it? Where it is received and re-amplified by Earth station and terminal. Okay, I expand, which is from satellite to the Earth station. They are received and amplified. When the signal back to the Earth is re-amplify and receive. Okay, next. Next is frequency. Okay, in this link we use frequency to transmit a signal. Okay. Okay, there are used two frequency, which is C band and Q band. Okay, C band use 604 gigahertz. Next is Q band use 14 and 12 gigahertz. There are two frequency dominant in this communication system. Okay, as we can see, K band frequency is more higher and C band is more higher frequency in uplink than a downlink frequency. Okay, why? Why do I use uplink more higher frequency than a downlink? Because signal there have to cross the atmospheres, which present a great deal of attenuation. The higher of the frequency, there are more signal loss, and there are more power need the reliable transmission. Okay, why use higher frequency if the signal loss and you need more power? Okay, it is because lower frequency get reflected by atmosphere bands and cannot get through the satellite. Okay, now satellite. I repeat, satellite is a lightweight device which cannot support high power transmitter on it. So it transmits at the lower frequency because satellite cannot afford power, so they are transmit with the lower frequency. As compared to the stationary Earth station, can afford to use a very high power transmitter. This is compensated by using highly sensitive receiver circuit on the Earth station. Okay, so as we can see before, there are uplink is more higher frequency than a downlink because a stationary station can afford a very high power, so they have more power. Okay, when from a station to a mobile portable device, so the mobile portable device which cannot afford a very high power transmission as a small battery and a limited power. Okay, the higher the transmitter frequency, the higher its loss. Since a mobile station can afford to transmit at higher power to the compensate for this loss, it must transmit at a lower frequency. as a lower frequency present less surface-based path loss. Therefore, mobile to base station uplink, which is uplink frequency, are lower than base station because mobile device cannot afford a power. Okay, that's all for me.
My name is Batrisyia and I'm going to explain the last slide, which is the block diagram of Earth Station. As you can see, the block diagram consists transmitter and receiver as usual, and they require high powers, most sensitive transmitters and large diameter antennas. The first segment we look at the transmitter, which is receiving the data from around the world and is called the uplink, as we told before. Then the incoming data are multiplexed and are modulated to an intermediate frequency of 70 MHz in the modulator. The IF, or the intermediate frequency, chosen as 70 MHz by using a transponder having bandwidth of 36 MHz. Then it goes to up converter, performs the frequency conversion of modulated signal to higher frequency. This is because the signal will be amplified by using high power amplifier and radiated to the space. Then Earth station antenna transmits these signals. Next we go to the receiver. The signal received by the antenna are directed to this receiving Earth station. It's called downlink signal, as we told before too. This is a low-level modulator RF or radio signal. In general, the received signal will be having less signal strength, so the low noise amplifier is used in order to amplify the signals and are converted to the intermediate frequency signals, which is either 70 to 100 MHz. Then it goes to demodulator to get the original signals and goes to decoder, which is the function is just opposite to the encoder. The decoder produces an error-free binary information by removing the error and correcting the bits positions, if any. Then the binary information is given to the baseband equipment for further process and delivers to the terrestrial network. The last one you can see here, the tracking subsystem, which is the one signals transferred after low noise amplifier. This tracking subsystem is keeping the track with satellite and sure the beam comes toward it in order to establish the communication. It performs mainly two functions, which are satellite acquisition and tracking satellite. This can be done in one of them and are automatically tracking, manually tracking, and program tracking. So I hope the information given will make you understand more about the satellite system. Thank you and feel free to drop any question.